Hi guys, I'm Catherine Cantley, and as this newsletter says, I am new to TechHelp and working with our food manufacturers here in Idaho. One of the things that I really want to do when I join this team is to record little videos, just little tidbits, nothing formal, teaching the group how to do something maybe they've been wondering how to do. Well, my background started out in process engineering. I did a lot of process engineering work with food manufacturers, including everything from pilot scale to experimentation, designing the process, commissioning the line, following up, doing installations, all that kind of stuff. Spent a lot of time in our factories. And then after that, I moved into the sensory and consumer science, which is really more about defining what the bullseye and the target even should be. What should our guardrails be for our production and the product itself, and things like shelf life and a lot of that other stuff, which, trust me, I'll talk to you all about in upcoming little tidbits here. Well, today I wanted to talk just a little bit about one of the things that I get asked about quite a lot, and I think it's sort of the foundation for when we start out doing any work in our manufacturing locations. We really need to understand how much variability exists in our operation and in our line. One of the things we need to do is measure something about our line to decide what kind of a sample size do we need. How many times do we even need to measure it? So to do that, I wanted to tell you a little bit about a guy named Dr. Deming, Dr. W. Edwards Deming. He did this experiment that's relatively famous with statisticians called the funnel experiment. And I drew a little picture, and forgive me, I am not an artist, but I drew a little picture here. Okay, so Deming did this experiment called the funnel experiment. He had He had a funnel that was fixed. It was on some sort of contraption that kept it fixed. And beneath it, he had a bullseye. And now you would think if this thing was fixed and as the marbles dropped through it, you would think that it would always land on the bullseye. But in fact, that actually wasn't the case. What happened is just with random chance, they kind of fell in this pattern that was a little bit all over the bullseye. There was some sort of discrepancy away from the central point. Now, this is a little bit interesting, right? It says that if I took the average of all of these, what we might call a displacement from that center point, if I took an average of all of that, I'd probably come up with an average that is the bullseye. But I don't want to have to measure it this many times in order to figure out where my bullseye is. I want to measure it the least number of times I possibly can get away with so that I am using my time effectively, right? So we need to figure out, okay, given this kind of spread or this kind of distribution, what do I do with that information? Now, a lot of people, for some reason, they think that if they measure it 3 times, that's good enough. Now, if you use this as an example, you just say, just by chance, just pure chance, I measured it 3 times. If I measured it and they just happened to land right here, these green ones, let's see if we can do that in there. Now, the central point here, the average, would be like right about there, right? Now, if I got, and I was doing it, and my 3 that I did were here, here, and here, maybe my central point is right there. And all of that is just pure circumstance and chance, right? The problem is, if we only take a really tiny sample size, not knowing enough of information, we may actually get the wrong answer. And that is not what we want to do in our factories, because we really do want to be as efficient and effective as possible. So there's a few pieces of key information you need to know. And this isn't really specific to anything. It's not specific to process engineering, or whether you're doing taste testing and consumer science, whether you're doing nutritionals, you're really using the same kind of principles. You need to understand a few key pieces of information, and I'm going to show here my screen. I made a little Excel macro that you can make too, actually, and I'll show you how to make it. Or if you want, you can just reach out to me, send me an email at catherinecantley@techhelp.org, and I'm happy to send it your way. So let me show you here. Okay, so you can see here now my screen and some of the things I've laid out. Now, confidence level. Confidence level says how confident or sure do I want to be that I have the right answer. In the food industry, a lot of times you'll see either 90% confident or 95% confident. If you're really risk averse, or if you're doing something related to regulatory like food safety or nutritionals, you may want to err more towards the 95%. If it's something that's not that big of a deal, but you do really want to have the right information, maybe you do 90%. So what are some things that I might use this for? maybe I want to see whether I'm maintaining the proper color in my finished product. Or maybe I am looking at something related to nutritionals and I need to make sure that I'm always staying within a certain range. Otherwise, I could have some regulatory issues or some claims related issues. Or maybe I just want to look at something that's varying about my process. Maybe my packaging operation or the metering of an ingredient, how much variability I have in that metering of the ingredient, and how does that affect the finished product. There's so many different things you could use this for. But let's take a look. The few pieces of information, confidence level, so you get to decide that, 90 or 95. And then the second piece of information that you'll really want to know is how big of a difference are you wanting to detect? So let's say I was looking at color. Maybe my current color has an L value of a 55, and I would really like to know if it was even 1 point away, or maybe I want to know that it's 2 points away before that would produce a different quality standard or something like that. So you can set whatever difference it is you want to detect. You can put that in this green button here. So let's say I wanted to be able to detect a color difference of 2 points away for L value. I can put 2 there. But maybe over the last month, I've been kind of looking at color for this specific product, and I've noticed that my standard deviation, if I measure that, is something like 3.5, let's say. Now this here, if you have no idea what it currently is, a good rule of thumb, there's some statistical papers on it, is to start by measuring that thing 12 times. You may have some electronic or digital data on that already, but if you don't, you might measure it 12 times and get a feel for what your standard deviation is today. And then what this does is it pops out the sample size required. If you want to be 90% confident in your answer, or let's say 90% confident that your color will stay between 55 and, well, let's say 54 and 56, so within 2 points, then you're going to have to measure it 9 times. If you want to be 95% confident, you're going to want to measure it 12 times. Now this can change, quite a lot. And like I said, now let's just take a look at this real quick. If I wanted to be able to detect a difference of only 1 point, you're going to see that because my standard deviation now is more than 3 times larger than the difference I want to be able to detect, that means there's a lot of noise in the system, and it's going to have a hard time, which means that to be 90% confident, my sample size has already increased to 34. So you can see that depending on how small of a difference I want to be able to detect and how that balances out with how large my standard deviation is or how much variability exists in my system, that may actually affect how big of a sample size you're going to need. Now let's take a look at how this actually works to see if you guys want to build one on your own. So 90 and 95, those are just your confidence intervals, and those would stay fixed. Difference you're going to set based on how much of a difference you want to be able to see, depending on what it is you're measuring. Standard deviation, you're just going to measure that and do a calculation. You could say, for example, you could have a column of data here and say equals, let's see, actually let's just write the equation here. It would be equals standard STDEV parentheses, and then you could select a bunch of data and then end parentheses, and that'll be what you want there for your blue box. So you're going to want to know your standard deviation. And now the way I calculated this is you're not going to want to change these, but it needs to calculate a z-score for this fancy little equation down here. And if you want, like I said, I will send you this file. Just send me an email, catherinecantley@techhelp.org. But what it does is it's going to take your confidence interval and divide it by 2, and then it's going to look up a z-score for that particular alpha value, or that all is based off of this confidence level. And then this formula down here it looks fancy, but you're going to use this round up since we can't take 34.5 samples, which are really going to be a 34 samples or 35 samples. But it's a calculation that is just a written representation of this equation down here, this n equals z sigma over e squared. So that's it. That's a simple explanation for how you can calculate sample size required for whatever operation you're looking at. It could be nutritional, it could be ingredient addition, something related to throughput, capacity, packaging, anything you can think of. anytime you need to be confident in your answer, you're not going to want to measure it 3 times for sure. You need to figure out exactly what that sample size is in order to be confident, particularly if there's a regulatory implication like a claim or nutritional fact panel or anything related to food safety. Those are going to be super key that you get it right. Signing out now, just wanted to share a little something with you. You can expect these little snippets as part of the monthly webinar, and I hope you guys reach out to me. Thanks. Bye.